Says that welcome to this presentation concerning about RI-SCALE and Data Exploitation Platform vision. Yes, my name is Ville Tenhunen, and I'm working for the EGI Foundation as a data solutions architect, and I'm a technical coordinator of the RI-SCALE project, which I present also here. Basically, the idea of this presentation is to deliver information about data exploitation platform. What is it? Why is it here? And who should be interested in this platform in the future and so on. Okay, first, let's setting the scene a little bit. The data deluge is not over yet. Actually, it's in good shape, and the amount of the data is growing very fast and very much. And here is some graphs about some genomics, bioimaging, and other omics data amount increased and volume increased. And you have to notice that this is a logarithmic scale, what we are presenting here. So we are facing all time more and more data, which have to be get in use, because data is always valuable when you use it. Data in outside of that is not so valuable anyway. Another big thing is that AI is shaping scientific research. There is plenty of different kind of projects and initiatives to include AI components and AI usage in scientific research. Here is some of those numbers that what we have seen in our communities, and for example, European Molecular Biology Laboratory, there is AlphaFold which is induced and so on. Third landscape issue is that Europe leads in research talent, but we are falling behind almost everything else. If I pick one number here from here, it's this number 5%. It's a EU's global share of the AI computational capacity. Of course, big amount of capacity comes from US and Asia and so on, but and here we are behind our share with everything else. So we have a number of different things to do to get all these things in a better shape. So challenge what we are tackling with the RI-SCALE and data exploitation platform is presented here. Computing power is where the data is not. Data and computing are pretty usually in different places and so on. There is a lot of different kind of cloud solutions and huge PC solutions and data repositories and so on, but they are not in the same place. Data access and transfer can be cumbersome sometimes. Repositories generates no value, and access to this data and transfer is difficult for scientists and so on. Third challenge here is that tool setup and integration pose high technical barriers, meaning that researchers have to have proper tools to generate and use AI and AI environments and combine the big data with that and get the results out. Okay, our solution in our RI-SCALE project is the data exploitation platform or platforms. I will explain a little bit later that we are actually doing more than one of them, but concept is basically one. The basic idea is that, okay, we have a RI data holdings or data spaces, and then we have infrastructures, we have a computing power, and then we have set up the partnership between these two players of the whole picture. And then the toolbox comes from the AI frameworks and models and data lifecycle management. And of course, we need trust and identity management tools and solutions to fulfill all kind of security requirements and so on. Data exploitation platform, a little bit deeper. We have three kind of users defined here. We have end users, and basically they are secondary data users because the primary data users are in RI facilities, and RI and data holders, they have a primary users of the data. But those data which has been replicated to the data exploitation platform, then there is data users who are so-called secondary data users. We have a model developers which develops AI models, training them, retrain the existing models and so on, and keeping also part of the toolbox in shape and so on. Data exploitation platform operators are those people who are working with this platform and creating integrations, keeping applications up and running, and so on. A special thing is this authentication and authorization and credit allocation, which are crucial for all these models and applications what we are using here in the platform. Data, of course, there is a plenty of data functionalities like discovering functionalities, replication, and whole data lifecycle management and orchestration. AI model development functionalities are coming from this AI workflows like model development, training and validation, and model deployment for the usage of the end users and so. Okay, project in nutshell. This is this kind of a short one. So EGI Foundation is the coordinator of the RI-SCALE project. We have 29 partners, budget 10.5 million euros, and we started beginning of the March 25, and this will take. We are closing the project at the end of the February 28. Our partners, there is a research infrastructures like IS-INES, iSCAT, BBMRI, ERIC, and Eurobioimaging. We have a computing infrastructures from TÜBİTAK, Technical University of Vienna, and EGI is taking also working in this infrastructure part. All partners include also developers. There is a data holders. There is other infrastructures, and also companies and SMEs and so on. We have plenty of good partners in this project from the different kind of approaches. Okay, in this project and this data exploitation platform will be validated by scientific and technical use cases. We have 8 scientific technical use cases here. First ones are about climate modeling. Number 1 is a high resolution downscaling of climate scenarios and risk trend analysis in agriculture. We have one demo concerning about this use case a little bit later in this presentation. Then smart detection of anomalies in climate data usage is another one in this domain. Near Earth geospace studies, and here we have iSCAT use cases, intelligent scheduling of the radar observation and experiments, and space debris and anomaly detection. Looking for a little bit sensitivity and health data. We have a use case about cancer treatment by BBMRI and Masaryk Cancer Institute. It's about colorectal cancer prediction with the explainable AI. and synthetic data for computational pathology. Then imaging in life sciences is a one section where we have a lot of data and pictures, and there we have a Euro bioimaging and EMBL. Foundational models for heterogeneous biological image data and generative AI-powered assistance for data discovery analysis are those use cases where we are using data exploitation platform here. Technological validation use cases are about Euro huge PC. We would like to see that those technologies and methods what we are developing in this project are possible to use also with the Euro huge PC facilities. So we would like to test these runs in Europe's largest supercomputers and so on. Image compression is one of these by BBM-RI and Masaryk. Green computing by Technical University of Vienna and Masaryk and Fragmentics. This is one important topic when we are doing this kind of computing. And the credit management, where we are dealing with the data exploitation platform and its resource usage and how to measure it and what is the environmental impact and express them in the form of credits and so on. EGI, GRNet, TÜVDAK, the Technical University of Vienna are key players here. Okay, when we are looking for this kind of simplified data science workflow, meaning that when data scientists are doing the research and work, nowadays, someone could say that nowadays all the scientists are some kind of data scientists because data is everywhere and all kind of research, almost all kind of research requires some data. Of course, there is something where we are not facing so much data, but anyway, and they are of course important science also. But basically, we have this kind of general workflow where the scientists have a problem, they have to define the problem, then they acquire data, inspect, clean, and prepare that one, explore the data, what's there, and then create the models and train the models and evaluate what kind of results this data gives, and then visualize and communicate the results and creating after that, writing the papers, publishing things and so on. If we think that, okay, where we are with the data exploitation platform here, we are trying to and we are fulfilling multiple part of this workflow. Of course, we are not defining the scientists through problems or publishing the articles concerning about researchers, but almost all different kind of workflow parts we are offering something from the data management lifecycle or AI management lifecycle, and of course access control, credit management, computing resources are present in every step here. Of course, there is a possibilities to show different kind of workflows, and there is some of them where we are not so much presented. But anyway, this kind of basic user workflow is in our focus also. Higher level architecture of the data exploitation platform. I show you a little bit more details about these boxes, but basically we have these three work user groups here, and we have a data holders and holdings as RIs and data spaces, and we replicate data. Then we have a data lifecycle management part where we orchestrate the data and store this replicated one. Then we have, of course, all this AI lifecycle management part, giving the tools for AI development, and all of these parts requires the authorization and credit management part. And of course, then we have to link all of these processes with the computing facilities and making technical validations of the whole thing. Meaning that data lifecycle management, we have a few components here, like a file transfer service, data management, discovery, popularity, and preparation services, and we are using components from CERN, FTS for queuing, scheduling, dispatching, and so on, and Rusio to organize, access, and transfer, monitor, and recover data. So we have and those tools has been developed for the big data and big data management also. AI lifecycle management, so far we have a few components also here. This part of the architecture contain this job offloading and orchestration, provenance tools, interference API keeps integrations on with the other components of the whole thing. AI framework, AI model hub. AI framework contains those tools to develop and manage those AI models. AI model hub is already there, or the first version of it, and this gives the visibility to those models what we can use in the data exploitation platform. Of course, training interference pipelines and metrics loggers are needed also for this component. Main components, interlink and itwinai from InterTwin project actually are presented here, and UProv for logging and tracking provenance information in machine learning experiments are used for the provenance part. AI Model Hub, it presents this scientific AI models utilizing the Hive backend, and XOPAT is a directory browsing and viewer service in this part of the architecture. Then credit management system contain this credits allocation registry and credits distribution policy management, and credits translation policy management, and resource usage and environmental impact tracking. Here is a number of different kind of registries, and the system gives the visibility that, okay, how we are using those resources, what are they in their environmental impacts, and so on. Authorization framework, which is very important for the whole platform. Here we have open digital rights language policy repositories and open policy agents, and we are controlling access with multiple different kind of access methods like EGI check-in, keylog, Indigo IAM, life science, AAI, and so on. Here is the one challenge is, of course, that the nature of the data exploitation platform is federated. So we have multiple organizations and multiple infrastructures in different locations with the different policies to integrate into the one platform, meaning that they have to be very careful with these authorization things. Okay, we are doing here at the first phase 4 configuration options, and they are, because the workflows with the RIs are not the same all the time, then there is also possibilities that there is a different kind of contracts, agreements, restrictions with the data usage, and so on. Some organizations are more networked than another one, and so on. So we are doing in this project 4 different kind of configurations. The simplest one is the one data holding and one data exploitation platform. For example, this ISNS use case is for this kind of solution. Then there is a number of different kind of data sources and one data exploitation platform, such RI-SCALE Pro case. Then there is a one data holder, but multiple users, like urobioimaging. And then finally we have the most integrated one, where is a multiple data holdings, and then there is a multiple data exploitation platforms like BBM, RI, ERIC. These are also mentioned clearly in our key exploitable results list, and therefore we are focusing also for these. Demo. Okay, itwinai workflow. This is for the scientific use case number 1, high resolution downscaling of climate scenarios and risk trend analysis. And well, basically this is about itwinai, which is a key component of the AI lifecycle management. The idea behind this component is to streamline AI workflows while reducing complexity and so on. Yeah, okay. This demo has been made by Alex Grochak from Jülich, and yeah, we have a video, and now I'm going to start that one. Just a moment. Share. No. No. Here it comes.
About itwinai as key part of AI lifecycle management in DEP, and in particular, itwinai will be showcased through the first scientific use case of a RI-SCALE project. So itwinai is a core component of the data exploitation platform, and more specifically of the AI lifecycle management. So it's responsible for distributed training, inference, hyperparameter optimization, and many other features. Is, let's say, the core training part of AI lifecycle management. And as the DEP develops, it will also interact and let's say entwine more closely with other parts of DEP, such as the AI model hub, or the data and access management work package, or the provenance, or many other parts of DEP. If you are interested in more information, I suggest you look at this open as another record here in the corner. And now about the scientific use case. So this is the first scientific use case of the RI-SCALE project, and it focuses on the climate scenarios and risk trend analysis in agriculture. Now, the core idea of this use case is that there is climate forecast data available, but not at the necessary resolution. And the idea is to train a machine learning model that can perform quite aggressive downscaling. So going from, let's say, 100 kilometers to all the way down to 5 kilometers resolution. And the way in which this will be achieved is through consequent usage of so-called SRCNNs. So each SRCNN will downscale by a factor of 2 or so. So starting from 100 kilometers, we'll go to 50 by 50 kilometers. Then we go from 50 to 50 by 25, then 25 to 12, and then 12 to 5. So each layer will, let's say, increase the resolution by a factor of approximately 2. And in this demo, I will focus on the first layer, so first SRCNN of this ML pipeline, because in principle, they all operate on the same principle. So just the input and output resolution of the data changes, but the workflow is the same. And in the first, let's say, steps, in the first stages of this use case, we train the data only on a small spatial patch of data, approximately 1,000 kilometers per 1,000 kilometers. But now we are training it over the complete SARA data set, which is of continental Europe. All right. So before I go into more depth about the code part of the demo, I want to give some more background about the pre-processing and of input and output data. So as a first step, we have netcdf temperature data at our input resolution. So for the first SRCNN, this will be 100 kilometers resolution. And we have this data for the time range from 1990 to 2014 every day. So daily average data, which comes out to approximately 5,000 samples, where each, let's say, spatial domain is 41 by 41 pixels. And the temperature range will be from 255 to 310 Kelvin. At the same time, we also have elevation data in the netcdf format at the same input resolution, of course. And of course, it's only one sample because this doesn't change with time. Now, in our itwinai pipeline, this whole data loading process is streamlined. So we have the class read features in which there are several methods. First method read reads the temperature data, read topography, then reads the elevation data. And as a result, we have torch tensor or numpy array with a shape of n by 2 by m and m, where m is the spatial, let's say, size, and n is number of examples. Then we call the methods normalized temperature as well as normalized elevation. And these methods are distinct because the nature of the data is distinct. So for the temperature data, it changes every day as well as spatially. So that's score normalization based on the mean and standard deviation is used. And for the elevation, as it's static and doesn't change with time, min-max normalization is used. So after these two steps, we have torch tensor in the same shape, but the data is rescaled. I think this is mixed up. So now it will be from range actually from -4 to 4 and 0 to 1. So these labels are mixed up. After this, we call the interpolate method, because before we even do any machine learning, we actually want the input and target of the machine learning pipeline to be at the same resolution, so to say. So we just use bicubic interpolation, no machine learning, to downscale this to our, let's say, target grid size, which means that instead of 41 pixels, we're now going to have 82 pixels, but still the same number of examples. And again, we have two channels. So we have elevation channel and temperature channel. And as a last step, we unfold the data set. So we split it into patches of output size with a given stride step. Basically, in this process, we cut small, so to say, small squares of the target data set. And then we have much more examples for the machine learning to iterate over. So this will increase the dataset size from 5,000 to 50,000 while decreasing the spatial domain to 22 pixels. At the same time, we need to also perform preprocessing of output data labels. Now we actually already have the data at the target resolution we want. So instead of 100 kilometers, we have netcdf files at 50 kilometers. We only look at temperature data because we don't want to predict elevation. Elevation is known, it does not change. It's the same time range. Now, of course, instead of starting from 41 pixels, we already have 82 pixels to begin with. Again, we have a different class read labels, but read method is the same. It reads this temperature data. Unfold method works in the same way. It unfolds this into, let's say, squares of a given size. However, what's new is that now we also need to add a crop method to crop the edges of each of these examples, because during the convolution, what network will do, unless you, of course, use some padding or so, it will shrink the output. The convolution operation, as maybe some of you know, it will decrease the size. So to account for that, we use this crop method, which means that from 22 pixels, now we will go to actually 10 pixels. So it only, let's say, keeps the center part of the spatial domain. All right, so now we can go to the code. So I've prepared a short demo script. Let me run this. Yes. So this is what the input and second, I'll do it like this. Yeah. This is what input temperature channel looks like, and this is what input elevation channel looks like. Of course, this is all non-dimensionalized, so you see it goes from 0 to 1. And this, for this particular example, it goes from -2 to 1, but it has a range of approximately -4 to 4 for the whole data set. And this is, let's say, the original input just from the netcdf files. So this was already after the interpolation step. You see the resolution increase. Okay. So another thing I want to show you, because it's very useful for the use case itself, is that itwinai supports the so-called configuration files. So in this configuration file, we can note down all the relevant information, such as, for example, where our data is stored, where, whether we want to use unfolding, whether we want to, let's say, apply all these different steps that I described, or we want to skip them for some reason. We have the output size. We have, of course, that settings, the parameters for the machine learning training, the batch size, number of epochs, learning rate. So all these things are stored in one file. This file, together with the source code, is the only thing you need. And this is very helpful because, for example, if you want to perform some studies, you can just copy this file and change some settings, or you can even pass a command line argument to modify some of the settings in the file. So let's now try to run this config file that I just showed. So we need to pass exec pipeline command as well as the config name, because by default it looks for a config.yaml file. And now we see a bunch of warnings that should be removed, but the network is training. So if I look in the main directory, I should be able to find some checkpoints with the best model. So every epoch, it checks whether the model is performing better than the previous one or than the best overall. And if we have a new best candidate, then it saves it explicitly. Okay, so I'm not going to wait long for this. And now there's also some kind of validation pipeline that we can try to run. So I have a saved good model, let's say, from that was trained previously. And we can also look at how the model that we were just training performs compared to that. So first, let's say I'll show the good model. Boom, boom, boom. So this is, let's say, our, it's not, let's say, the full input, it's the input after it has been interpolated. But you see that because of the bicubic interpolation, it looks very, washed out and fuzzy and blurry. And then in the middle is the machine learning prediction. And you see that compared to the two, it increases the sharpness in key regions. And on the right is the ground truth. So in this particular case, it doesn't fully recover the ground truth, but we can see that it definitely improves it compared to just default bicubic interpolation. And of course, this is just an intermediate result. There's still more work to do. But now let's test it with what we just trained. So of course, we would expect this to be very poor because we only trained it for around 15 epochs. So scratch, checkpoints, best model. Let's call this, I don't know, dry run. Yeah, okay, we actually see that. I think maybe I can compare this somehow. Yes. So on the top we have the result from fully trained model, and on the bottom we have, oh, sorry, like this. Yeah, now on the bottom we have the result from the model we just trained for 15 epochs. And actually we see that it seems like the model doesn't really do much, probably because at the learning rate we picked, the weights haven't really been significantly changed. So it basically just passes the input to the output directly without really doing any upscaling. I mean, you see that, let's say, the first two images here are almost the same. And of course, yeah, the model output doesn't look anything close to the ground truth. And then at the, on the top image, we really see an upscaling effect. Okay, thank you for your attention. I hope that this demo has been interesting for you. If you have any questions, please don't hesitate to reach out to me. Bye-bye.
Okay, thank you, Alex. Let's go back to slides for a moment, and then we can take these questions. So hopefully this will tell about itwinai usage in the workflow, and yeah, this all the integrations and the end user interfaces were not in place yet, but we have a couple of years to do these projects. And yeah, we had this first release, and we have released some of those components and so on. There is the components for the data lifecycle management, AI lifecycle management, and access controls. And we are entering now a validation phase where those use cases will test and assess the deployed components and in a real world research scenarios, and then ranging those scenarios which ranging from the climate science to computational pathology and bioimaging and different kind of cases and so. This so we are testing that, okay, where we are going, where we are now, and then redefine where we are going, and then turn this project to that direction. So in the first release, we fulfilled 23% of our all requirements, and rest is coming to the second one, and then it takes 1 year to reach that phase. At the end of now we are starting summarizing these. At the end of the project, what we have then, we have a tool for research infrastructures and their users to extract value from the RI data or data space data. This platform also enables RIs and compute sites to establish their partnerships through software deployment and associated business models and so. So we are not creating this kind of static model and static platform, but this kind of tool to create partnerships also here. And we promised the vision of the data exploitation platform in the title of this webinar. So here it comes. Vision of the data exploitation platform is to empower research infrastructures that generate massive amounts of scientific data by providing them with the tools needed to fully exploit and valorize their data. So value out of the data they are using from in their own infrastructures and from their own data sources. Okay, that not all in this slide set, but you have possibilities to involve the project. There is a different kind of possibilities and different kind of approaches to join the project. First, of course, we have research infrastructures and computing and HPC providers, AI model developers, startups, SMEs and industry, innovation partners and ecosystem partners. All of these are, and perhaps some other ones are pretty welcome to involve the project. So there is something, of course, what these groups can do: contributing data, contribute infrastructure, models, solutions, and connect the partners and align the ecosystems. And how to get involved? It's something that is possible to start from the RI-SCALE webpage. There is a Get Involved page, and there is forms and more information about these possibilities. So thank you, and now I think it's a time for questions, and I hope that we have some here. So I stop sharing and
Thank you
in.
very much. Thank you. And we do have a Q&A session, which will be chaired by Alisa. Alisa, you're the chair of the session.
Oh, yes. So, Jill, if you could share also, we have prepared a Mentimeter so that you can express also your feedback here. So, first of all, we would like to understand what best describes your organization. So, if you can just access with your mobile in the Mentimeter, and we will see here also the answers that you are providing in the slides. I think that this is also useful for us for understanding what is the audience. I see that several people are already responded also, although we don't see exactly. We have now several of the answers there. Wow, that is very interesting. People coming from research infrastructures. That is the main audience. Yeah, thank you very much. So it seems that we are not having a lot of industry SME members yet. Maybe for the next webinar we will have more. Okay, so I think that we can move to the next slide. We will appreciate also your feedback. So what is your main interest today? So it seems that many of you are interested in learning about data exploitation platform for the first time and exploring whether data exploitation platforms are relevant for your organizations. Well, this is also quite interesting feedback that we are receiving. Yeah, well, you are quite active here. Thank you very much for this feedback. Maybe we can go to the next slide. Could your organization benefit from a data exploitation platform? Yes, possibly. Yes, definitely. Although we have some people here that they are not sure yet. This is interesting to know. Well, this is growing. This means that maybe we need to provide a little bit more of information here on or keep them more engaged on that. Interesting. Next slide. So what would you use a data exploitation platform for? Data organization, research, analyze, computational power, while you are providing several comments here. Data mining, data organization. Well, it's not hard to see people are providing. Okay. Well, it seems that our consensus about about the answers here. Next slide. So what are your main concerns or barriers regarding adopting a data exploitation platform? Okay, I don't know enough yet to say that's the answer that are most voted. So yeah, well, and the lack of in-house skills or expertise. So it seems that this demonstrates that this is a field that needs more work, more training, that we will need to run some other sessions for keep the audience informed and engaged. Okay, that's really, really useful. Okay, let's move to the next slide. What should the project do next to support engagement with or adopt deep technology? Some support and online documentation, training activities, open data, I don't know, explain similarities, differences, and advantages with respect to alternative platforms. Galaxy can be one. Interact with other research infrastructure to understand their needs, trainings, data, open data, well, some support and online documentation, provide concrete information, help desk, provide more detailed technical architecture. Well, it seems that what is really needed is more information. I think that we are identifying here a lack of understanding of everything regarding a data exploitation platform. Continue disseminating by webinars and documentation, define the target users. Well, we have defined the target users, even though it was not purely explained today in the webinar. Maybe that is something that should be more clear for next sessions. Okay, well, this will remain open. Next slide. How clear was the explanation? We would like to understand also how clear is everything for you. Okay. So we can say that the webinar was clear enough, but still you have many doubts, and that the concept itself and the scenario require more analysis and more information to be shared with the audience. This is interesting to see. Okay, and next slide, finally. So we open here questions. So this is free for you to provide questions if you want to be answered here directly. So this is, I guess that this is about access policy and data policy. This is not exactly a question, but maybe Ville, you can answer here.
Yes. Okay, access policy and data policy. Of course, we have multiple different kind of policies with the RIs, research infrastructures. They have their own policies, and then they have to give, of course, these permissions to use this data and so on. In this project, we are following these data sovereignty ideas and so on, that the control of the data which RIs are delivering to the data exploitation are all the time controlled by the RI itself. So data exploitation does not, how can I say, catch the data and take it as its own, but it's controlled by the RI in every case. And that creates the basis of the access policy and access policies, and we are of course harmonizing some of them and checking that okay, everything works together pretty well and so on. So that's a very important part of the whole architecture and whole project to manage all these policies and so on. Yeah, I hope that I answered the question properly.
Yeah. It seems that we have more, Jean. Press enter, I think. No. Oh, I think that there were some other questions there, right?
No, I couldn't see any other question. Oops.
There are a couple. Hi, so this is Mitesh. I see a couple of other questions. The first one I see is, what are the plans for training the RIs? Wille?
Training the RIs, and I mean that you mean that, okay, how we are going to give the training for the RIs to use all of these usage of the data exploitation and platforms and so on. Of course, we are going to continue these webinars, and of course we are creating documentation of these data exploitation platform components and how to use it and so on. And of course, we have some trainings, but basically, actually, as a matter of fact, Yin is our training specialist. If you would like to, how can I say, clarify or fulfill my answer, it would be good.
Okay. Within the project, we currently in the early stage. We more focus on the project level training, and then move when the technology development become more mature. We will definitely open up for broader user group. And yes, but we welcome your to follow up, to engage, and so we can keep your to notify any training about this. If you are not within the project yet, please do contact, reach out to us.
Okay, thank you, Yin. Thank you, Yin. Okay, next question is that how does a data exploitation platform integrate with the existing storage resources? Yes, of course, this goes the way that RIs have the existing resources, and we have done survey to evaluate and assess what kind of storages RIs have in the project. Basically, our tool to make these integrations are FTS and Rusio in the data lifecycle management component and so on. And so we are using these tools to transfer and making this data orchestration from the RIs. So RIs have to integrate to these tools, and that is the basic way at the first place.
Okay, we have another question that how could nuclear fusion community look for synergies with your project? Multiple large data sources are involved. That is a very interesting question.
Yes, nuclear fusion community. I think, okay, basically we have well, nuclear fusion community look for synergies with your project. Yes, these communities are very welcome to involve the project via this website, and then we can find the way which kind of part of the community is possible to involve in with the data exploitation platform or the RI-SCALE project. And data sources, yeah, they are welcome come to the project, because Basically, some of our KPIs include the number of different communities which are not involved in the project yet, and they should also validate our results and validate to our platform. And of course, this is also part of the idea that when we have data exploitation platform ready, and after the project, the life goes on, and then there is a possibility to start to use this data exploitation platform. Yes, and yeah, and via website, if you can take a contact and so on, and then we continue the discussion with these communities and so. But yeah, that's a very good idea.
Yeah, and there is one final question that I see is, can you describe the data flows from holders to the DEP a bit more?
Data flows from the holders to the data exploitation platform. Okay, I try to catch what what a bit more means, but yes, it comes from the basic idea. It goes in our use cases, what we have defined goes that way, that there is this end user, which I showed in the slides, and he or she is going to and he access to the data exploitation platform and the data management tools, and then the process starts, of course, that way that the scientists select which kind of data sets he or she would like to replicate from the RI to the data exploitation platform. It doesn't mean that all the data from the RI will be cached to the platform, but selecting the proper data, what she or he would like to use with those AI tools and model trainings and so on, and then the certain data will be transferred. And of course, before that, there is those agreements that, okay, which data is possible and where is the rights and what is the possible to access and so on. But the basic idea is that, okay, selecting the right data for the proper use and so on. Of course, there is a listings that what are the available data, and then selecting the right one, and then the tools are transferring those data which are needed, not big amount bunches of the data from the source. I hope that was a little bit more, and next time I promise to describe this a little bit better if there is a possibility. Okay.
Yeah, and yeah, there is one final question which is also on the screen about data spaces, and if you can describe more the approach of the project for integrating that into the EU data spaces.
Yeah, data spaces, they are coming into the picture a little bit more and more during the project. And basically, the basic idea is that, okay, we are facilitating and we are validating data exploitation platform functionalities and resources and integrations with at least 3 of data spaces. We have currently in our list, there is a Copernicus, UCAME, and Destination Earth, which data we would like to test, and it includes also testing these procedures and technologies with your HPC facilities and so on. Basically, these integrations are not ready or done yet, and they come when we are go a little bit further in this project and checking what kind of possibilities we have available. But we have also simple connectors mentioned also in our work list, and we have started also to do these testings and checkings that how good the simple is the way to integrate these data spaces with the data exploitation platform. And this connector world is also evolving all the time and so on. So we have to check that where we can do, but this simple is one possibility for data spaces integrations in this project also. But future shows that what will be the final way to do that. But that's actually this is a very good question. I like that. Yeah.
Okay. I think that's the last question, and then also we are running out of the time. And I think it's a very nice session. And I just want to give a thanks again to our speaker, Vila, and that's a very nice talk. Give to thanks to Alisa and Smitish, and to very nice preparation for this Mantis. Very interesting to me. Thanks to Rakash Sama. Thank you for your team for this demo development. Also give a great thanks to our audience for your engagement, your question and feedback. I hope you enjoy it, and I will contact you for the recording and the slides when it's available. We will reach out to you, and once again inviting you to get in touch and then to give your feedback, and we are looking forward to hear from you. Thank you. Have good rest of the day. Bye bye.
Thank you.
Bye.
Bye.